Hi, in this video we're going to make a very first program in ROBOTC for VEX IQ robot. Specifically, we're going to make a program that will make the stretch robot, which is the robot for the 2017 Ringmaster game, just move forward. A lot of the same logic works for the standard Clawbot. So what we've done is we have opened ROBOTC. We have the robot brain connected to the computer using the USB cable that ships with the super kit. So the first thing we need to do is we need to create a new ROBOTC file. And from this file, we're going to save this. All right, so the first thing we're going to do is we're just going to save our blank file. And hit save. From here, we just want the program to go forward. So we just want it to go forward one rotation of the motor at half speed. So let's download this to the robot and see what it tells us. It's downloading the program, and we get all of these debugger errors. So what this is telling us is that the brain detects 4 motors. The program is detecting all of these, expects all these other pieces. So we need to go reprogram what the robot has on board. So we're going to close out of the debugger. We'll go into the motor and sensor setup. And from here we can select a standard robot. So we are using Stretch, which is very similar drivetrain to the Clawbot IQ. So we'll just click there. And what this does is it removes a lot of these sensors that were initially included in the program. There are no sensors on this application, on this robot, so we're going to turn this off. So on this devices page, we have no sensors. And I'm going to leave these motors here and run the debugger again, and we'll come back and look at this. And click OK. Download it to the robot. Okay, so now our debugger is telling us that the brain can detect motors in ports 1, 4, 10, and 12, but the program is telling the robot it has motors in ports 1, 6, 10, and 11. So let's abort the debugger and go back and look at those motors again. So motor and sensor setup. So I am looking at the robot and I can see just the way that it's cabled that the left drive motor is in port 1. The right drive motor is in port 12. So we're going to move this. Say no motor. VEX IQ motor, it's the right drive motor, and that has to be reversed. I can see that the arm is in port 10, so we're good there. And in this robot, the claw motor is in port 4. So I'm just going to move this up. Say VEX IQ motor. And so again, there's a mistake here, but I'm going to leave it in just so we can show what happens. We're going to go apply. Click OK. Download it to the robot. Look what the debugger tells us. So we're getting closer. So the brain and the software see something on port 1. Brain and software see something on port 4. Brain and software see something on port 10. The software still has something configured on port 11. I moved one of the arms or the claw, and I didn't take out the motor. So let's go back to the debugger, or let's go back to configurations, edit, see where we have a motor selected here, but there's really no motor connected to that port. So we click no motor, apply, OK. Let's download this to the robot. Okay, we received no errors. And so now we can actually go onto the robot and click run, or we can click start from here. And here we have the robot just move forward, and we have our first program running. A note is with ROBOTC, you do not have to load programs into specific ports, that you just keep downloading programs onto the robot and you go ahead and you can delete those later, that you're not restricted to the however many ports that ModKit expects you to have. And with that, we've created our very first program that makes the robot move. Thanks much. Bye-bye.